Dear student, today we are from Gujarat University Department of Statistics, and I am Pravendra, and with me my senior colleague Dr. C.D. Bhavsar. In last lecture we have discussed analysis of variance for one-way classification and two-way classification, and today we discussed CRD, RBD, and LSD. These are the complete block designs and design of experiments, and today we discussed with brief in CRD, RBD, and LSD.
Dr. Parvinder had completed his PhD in design of experiment. He is an expert in design, and we see how he taught you about the design of experiment in details. So, Parvinder is there.
Completely randomized design. In short form, we call it as CRD. This is the simplest design, which is based on the principle of randomization and replication. In design of experiments, we study there are three basic principles: randomization, replication, and the local control. In CRD is based on randomization and replication only. Now suppose we have V treatments. We have V treatments and and homogeneous plots of say equal size and shape. Now we do not note down this point. We do not know any type of variation in the plots. We do not know any type of variation in the plots, any type source of variation. In the plots. And now we divide say V treatments into N plots such that randomly. This side we take treatments. So there are V treatments. We divide or we apply these treatments randomly to these plots, say, and the observation say it is y11, y12, say y1, r1. Here it is r1 plots. Yield or response for second treatment in this plot is 2-1, say y22, and this is y1, say r2. This is yv1, yv2, vth treatment, and this is y1, rv, r2 plots. We apply treatment 2 in r2 plots, we apply treatment 1 in r1 plots, and we apply treatment v in rv plots. And the sum of this jtx value 1 to v rj is n. Total are there n plots. Total are n plots. We divide n plots in such a way and allocate treatments from 1 to v. So this is how we divide or how we allocate different treatments in n plots. Here R1 and R2 and RB may be different, but the sum should be equal to n. Now we consider the mathematical model for this completely randomized design. Now, let mana yjk is the yield or response, or you can say response from the kth plot receiving jth treatment, and this is equal to yjk will be is equal to mu tau j plus ejk, where tau j it is mu j minus mu, where mu is the general mean effect and tau is the effect due to jth treatment, and this is eijk is the error effect, and eijk follow normal distribution with mean 0 and variance sigma square e. eijk are identically and independently distributed normal variates follow normal distribution with mean 0 and variance sigma square e. Now we try to find the values of mu delta j, and subject to the condition that the sum j takes value from 1 to b, rj delta j should be 0. Call this as equation 1 and call this as equation 2. Now using the principle of least squares, we try to minimize the sum of squares due to errors. E is equal to, say, where j takes value 1 to v and k takes value 1 to rj, ejk equal to summation, double summation, j takes value from 1 to v and k takes value from 1 to rj. From this equation, this is yjk minus mu minus tau j square, and now we differentiate it to find the value of mu. First we differentiate it partially with respect to mu. So when we differentiate, we will get dE minus 2 j takes value 1 to v and k takes value 1 to rj, yjk minus mu tau j, and put it equal to 0 and put it equal to 0, and this implies simplify. So this will be j takes value from 1 to v and k takes value from 1 to rj, yjk, and this will be, when we add it is simplify, mu is constant, so we takes it just outside mu, and this is k equal to rj minus j takes value 1 to v, k takes value 1 to rj tau j, and this is equal to 0. Now further simplify this. We get this is equal to j takes value 1 to v and k takes value 1 to rj, yjk, simplify this, k takes value rj, so mu j takes value 1 to v, say rj, and this value is summation j takes value v, and this is rj tau j equal to 0. So we will get from this equation this implies j takes value from 1 to v and k takes value from rj yjk minus this is the value of n, so this is n mu, and this value subject to the condition this is 0, so this is now, so this is 0, so from here we write it as the value of estimated, it is j takes value from 1 to b and k takes value from 1 to rj yjk divided by n. So this is the value of estimated mu, and for notation we call it as y dot dot. We can also write it as y dot dot. So keeping this in mind and this subject to the condition, the value of mu cap is j takes value 1 to b, k takes value rj, yjk divided by n, and we also call it as y bar dot dot. Now this is the value of mu. Now we try to find the value of tau j by differentiating it with respect to tau j. Now differentiate it with, we get, this is delta E delta tau j, differentiate with respect to